Hello all, welcome to the 11th episode of this Deep Learning with Pytorch series. So in the last video, what we went through was like very basics of Pytorch, how you can use different Pytorch functions to create certain uh, Pytorch tensors, how you can do the NumPy conversion to Pytorch tensor and the vice versa, and few basic operations like also how to build a simple feed-forward neural network using Pytorch. Right. So in this one, I wanted to take you through how to create a linear regression sort of neural network using Pytorch. So I will use the very basics Pytorch autograd function to calculate the gradients instead of like writing the equations for gradients, which I did for when I was going through the linear regression from scratch implementation using NumPy. So in this video, the idea is to use the Pytorch autograd function to do calculate the gradients and then use it. So at first, what I will do is I will import the required libraries, NumPy and Torch. Then I will create an input array. So this input array is a NumPy array where we have like 5 rows and three columns, which you can also see in the shape. So once that is done, I will also create a target, right? So if you see, the target has two features, right? 5 rows, two features. So it's like we will have two nodes at the output layer. So it's like a multi-output regression, which we are trying to do using this, right? So the if you check the shape of this, you will see like 5, 2 is the shape of my target. Right now, to work with PyTorch, you need to convert your NumPy array to PyTorch tensors, right? So this is the way to do it using this from NumPy function. Now, if I just run this, you will see the outputs are converted to torch tensors, right? So once that is done, we can go ahead and build a model, right? So just to give you a better visualization of this, so this is how the multi-output regression is, the model will look like. So we have three features in the input like x1, x2, and x3, and we have two output nodes, right? So because we have two features here, so that you can see when I've created the target, right? And so the weights and biases shape will be like the for weights, it will be like 2, 3 because we have two output nodes and three input features, right? So based on that, based on the understanding which we have gone through in the last few videos, right? So the shape of my W would be 2, 3, and we will have two biases for each of the output nodes, right? So that is kind of, this is B1 and this is B2. So the shape of B would be 2, right? So similar way, I am just creating this torch dot rand function. Using that, I will initialize the weight and biases with random values. And if you check this closely, you will see I have mentioned here requires grad equals to true, because we will need to do the backpropagation on top of these two weights of my model, right? So if you run this is the output, and after that, this is the shape of, I'm just checking the shape is similar like 2, 3, and the bias shape is 2, right? And then I will define the model. It's a simple linear regression model, right? So the model will, I've created a function named model where I will pass my input data to this, and based on that, it will do it will do the dot product between W transpose X, and it will add the bias term to it, right? So then once the model is created, we can pass my input to this model, and we will get the corresponding output to this, right? So you see the grad function also here, it is mentioned as th add backward, right? So then I will define my loss function. So using this loss function, we will calculate the loss. So how we are calculating the losses, we will pass our actual and predicted value. First, I will take the difference, then I'm squaring it, and then I'm doing a sum, and I am dividing the whole sum by the number of elements in that particular input, right? So this function, which is dot numel, will return the total number of elements in the input tensor. So this is a PyTorch function which I am using to get the total number of elements in the input tensor. So once that is done, I will return the MSC from this function as an output, and then I can calculate or compute the loss, right, by sending my predictions and also my target variable. So you'll see the loss for this is 10, right? So this is kind of a cumulative loss for all the training examples. And once the loss is calculated, we can compute the gradients. So how we can do it in PyTorch, we can call this loss.backward method, which will calculate the derivatives of loss with respect to W and B, right? So once that is done, we can access those gradients using this W.grad and B.grad. So that will tell you the gradient values, right? And it has been seen that PyTorch kind of accumulates the gradients like previous iteration gradients. If you don't do this dot zero in place operation on top of this two gradients, it will kind of keep on accumulating the previous gradients also. So at first we will kind of set it to zero, just that the accumulation doesn't happen. Then we can do the gradient descent operations, right? We will first pass my input to the model, which will generate the predictions. Once the prediction is done, we can check the shape just to make sure like things are working fine. The prediction and target or the actual or the prediction shape should be similar or same. And once that is, we have the predictions, we can pass the prediction along with the actual values to calculate the loss. So this is how the loss is currently looks like. And then you can call this loss.backward function, right? Once that loss.backward function is called, then my derivatives of loss with respect to W and B will be calculated, and we can access those values using this, right? W.grad and B.grad. So this value is kind of the learning rate which I am setting here, and based on that, it will do the gradient descent steps. So once that is done, we will kind of zero out the gradients, which was like calculated using this backward call, right? And if you see the new thing which has been added here is torch dot no grad, right? So PyTorch kind of calculates a computation graph, and it kind of adds each of the operations that are being done on top of the model weights, right? Where we have mentioned required grad equals to true. So we have mentioned required grad equals to true for these two variables. So these are the operations which we are doing on top of W and B, but we don't want to add these operations to the computation graph, which will not be used during the gradient calculations, right? So we want only the model function, right? This operations we only need to calculate the gradients. We don't want the gradient descent steps to be added back to the computation graph. So that's why we are kind of using this torch dot no grad. So once this is done, we can go ahead and make predictions and calculate the loss. So you see like the starting loss is very high, right? Because we have done only one iteration on top of my data. So just to make everything bind and do a full pass through my data multiple times and do multiple iterations, we can initiate a for loop. And inside that for loop, we can do the operations which I have talked one by one, right? So first we will pass my input to the model, then we will get the prediction. Once we have the prediction, then we will calculate the loss. So we are also printing the loss uh, at each iteration. And then we are calling this loss dot backward. And then we are using this torch dot no grad. We are asking PyTorch to not to add the below operations to the computation graph, right? So this is where we are doing the gradient descent step, right? So if you see like with higher number of iterations, so we iterations we also call as epochs. So what epochs is and what iteration is, I will uh, take you through in detail in the next few videos in this series. But if you can see, like with increasing iterations, the loss is kind of decreasing, right? So it's like the learning is happening at the model parameter level, right? So now if I check my final target and predictions, this is how it looks like. So this is my target, the actual value, and these are the predictions. So with this number of predictions, with this number of iterations, your predictions are kind of very close to the target value, right? So if you do multiple iterations or we kind of change the learning rate and all, we can make our predictions so much close to the target value or the actual value, right? So yeah, so this in this short video, as I just wanted to give you a flavor how the PyTorch functionalities works in terms of uh, the backward method, then the how we can use the gradients to do the gradient descent step, and also the concept of zero grad, why we need to do the zero grad, right? So if we don't do the zero grad here, so that in the next iteration, this gradient will be added back to the current steps gradient calculation, right? Just to avoid that, so that the gradient accumulation doesn't happen, we are zeroing out the gradient after doing the gradient descent step, right? Okay, so yeah, that's all I wanted to talk in this video. I hope you like this. So if you like this, please share and subscribe this channel, and also share this with your friends. Thank you all. Thanks for your time. See you in the next video.